Hey everybody, Lars here. Time to begin the review videos for Unit 3. I know I've made Unit 3 sound all scary and kooky. Hopefully you've already had a look at the slides. It's a longer unit than your previous units because it breaks down, in a regular semester, it breaks down to 3 weeks instead of 2 weeks, and it's basically 3 different sections. The first section being functions, the second section having to deal with files and file I/O, the last of the sequences, and then the last part talks about libraries and modularity and being able to create libraries of our own, start thinking about third-party libraries and things along those lines. So tonight we're just going to deal with the first part of the slides where we deal with functions. If you've read the slides and you think about it, they all extract out to one thing. The concept is modularity. We're now at the point where we have some problem-solving skills under our belts. So now we're going to think a little bit bigger and start thinking about compartmentalizing or modularizing our problem-solving techniques so that we take big problems and we turn them into a bunch of little problems, and then we solve those little problems until we can put all those solutions together and get big solutions. You'll see where I'm going as I go. Let's get started. I already created a file for us, not that one, this one, where we are going to be able to play around with functions. So the first thing we're going to do is, I'll call it my list. I'll create a simple list, and that's good enough. And what am I going to do? I'm going to print their sum, but what am I going to do? I'm going to use a function. Hold the phone. Okay. Save and run. All right, so let me get my code near my run. Okay. For those of you who don't know, Python has a group of built-in functions. We're going to look at them, some of them, in a second in the Python documentation. But sum is one of them. In the past, I've had students use sum as a variable name, and I've had to say, don't do that. You need to avoid it. If you can notice, idle turned to purple. That's what idle does with functions. So whenever these students would type sum, it would turn purple, and they'd be like, what's going on? And I'm like, wait till the beginning of Unit 3, and we'll get through it. But you could see the sum function takes any iterable, or something you can iterate over, a sequence, and gives you the sum of it. So if you look at all these numbers up here and you sum them up, it would be 37. Thinking of things as far as we're concerned, the anatomy of a function, the name of the function would be sum, S-U-M. Okay? The arguments or the parameters sent to the function, which is just a small little subprogram at the end of the day, and we'll see that in a second when we create our own. The argument is just the list. And like I said, you could send integers, floats, strings, a combination of all of those, or you could send more complex objects like this list right here. So the list is the argument. And then the third part of a function is the return. What am I getting back? What's the answer? What's the return value? And in this case, it's over here. It's 37. 37 is the return value. Okay? Now we can also, and I'm doing print. We could do it in the command window too. Another one we've seen already is type. I want to know what type of data I have. So I run that, and it tells me I have a list. And you see class. You're going to learn all about what that is come Unit 5. Okay? So in this case, type is the function name. My list is the argument. And the return value is class list, a string that says class list, to tell us what kind of value we have. As I said before, third part of this unit, you're going to learn about libraries. You're going to learn about third-party libraries. But this, if I'm not mistaken, I have it brought up. Yes. These are built-in functions that we're dealing with here. I actually have the Python 3.4 documentation up. docs.python.org is your best friend. You can go there and just start reading. And it will tell you everything about Python and everything about the language. This, believe me, if you're a Python programmer, you go to this thing every couple of days, because it tells you everything. Okay? Right now, I'm looking at the section for the Python standard library, but these aren't in a standard library that we need to import. Like I said, you'll learn about that in the third section of this unit. These are built in and ready to go. As you can see, when we did our code, I did not import any library, or I did not tell Python to do anything special. I just typed sum. I just type. Okay? And as you can see, type, sum, these are in here. You've already used sum already. You've used input. You've used integer for casting. You've used string for casting. Float is here as well. So you're already familiar with some of these built-in functions. One thing that's neat about this particular page is I can come to the sum, click on it, and it'll tell me about it. Okay? It'll describe the function, what it does, how it's used, and it does this for all the built-in functions. So this is really helpful if you want to use the documentation. I mean, this is the main page. There's a tutorial, there's library references, language references, setup and usage. I mean, how-tos. This is really good stuff if you want to learn Python. I mean, well, the really good way to learn Python is to do what you're doing. You take a class. But when you're done and you're going to want to either refresh your memory or go learn something new that's a little bit more complex or go do some other things, this is where you come. The Python documentation is it. It's fantastic. And it's where you want to be. Go read the FAQs at night while you're laying there with your iPad or your Kindle. Just pop the FAQs and read a couple. All right, it's a really, really, really great resource. All right, I am through beating that particular dead horse. Let's come over here, and I have called this funcs.py, and funcs.py is going to be available in your Unit 3 resources when I'm done with this, so you have no worries. Don't worry about typing it all. I'm going to comment this out, or string it out, as the point may be, and we are going to create our own little function. I've done these videos in the past. I have wrote a function called multi-square. I've written a function called multi-cube. And so I don't know that I'm going to do multi-quartic or whatever something to the fourth power is. I think I'm just going to do multi-cubed again. So how do we create and use our own function? First thing we're going to do is we're going to type def, D-E-F, which could stand for define, it could stand for definition. To be honest with you, I don't know. But when we create functions, we want to put that keyword in front. Basically, what we're telling Python is, hey, we're about to define a unit. We're about to define a function, so just stick it in memory. We're not really going to run any code yet. Okay, so what's the first thing I'm going to put down? I'm going to put down the name, and I will do multi-cube. So I put down a name, multi-cube. Then I want to put down what variables I want to use. So I'm just going to be real simple here and say I'm going to have two variables called A and B. Then, because I'm going to start a block to do my function, I give it a colon. And idle indents it 4 for me, so I am ready to rock and roll. Now, and when I'm done creating this, we'll use it and then go through a trace. So right now, I'm sitting here, and I have a variable A and a variable B. And what do I want to do? I'm going to create a variable Z that is the product of those two things. And then as a return value, I'm going to return Z cubed. Okay? And as you can see, after the return value, idle took me back to the beginning, because when I do the return, that means I'm probably done with my function. So idle's got its stuff together. All right. Let's use that, and then we'll discuss it as I'm using it. So I'm just going to say print multi-cube, and I will do 2 and 3. And what would I get? Let's see, 2 times 3 is 6. 6 cubed, 6 times 6 is 36, times 6 again is 180, 36, 216. Da-da. 216. Okay, so multi-cube seems to be working. Let's trace through the program. Starts up here at the top. I have a whole bunch of comments. Boom, boom, boom. They get ignored. Uh-oh. 3 single quotes creates a big string. I'm not using it with anything, though, so it just sits there. Acts like a comment. All right, now I get the def keyword. That means I'm not really running anything. I'm about to define something. Okay? I give my function a name, multi-cube, and I tell it in parentheses the 2 variables or parameters or arguments that I want to work with. Okay? Then colon, boom. Then I create a new variable. I call it Z. Now, I can create a variable out of thin air there because there's nothing blank over here to be evaluated. These are going to be evaluated, and this variable is going to be initialized. So you'll see later, we'll have to zero out some values when we do the Euler stuff. So right now, Z is A times B. All right, whatever. We'll get to that in a second. And then I return Z cubed. All right, that's all going into memory. We're not doing anything yet. I drop down, comment, main program. Now we get to the nitty-gritty. Using the print function, print what returns from multi-cube 2, 3. Okay, so when I call this function, what happens? Python goes into its memory and comes up here and says, okay, multi-cube. The first argument was a 2. I'm going to make that A's value. And the second argument was a 3. I'm going to make that B's value. So when I drop down to this second line, A is equal to 2 and B is equal to 3 because that's what I called it with. Okay? So Z now equals 6. So drop down to the next line. Return. I'm already ready to send the return value back to where the call was. Z cubed. So 6 times 6 is 36. 36 times 6 is 216. I return the value 216 to the original call, where it is then printed. Okay? Now, if I do the same thing, print multi-cube, let's say 2, I get 64. Because now I'm running through the process with new numbers. Okay? So that's what you use a function for. You use a function because you have some small piece of functionality that you want to compartmentalize or just code up and put off to the side. Then in your program, you can use it. So when you need to do that particular function, you always have it sitting there. You don't have to code that logic every single time you have to do it. Now I have something to call, and I can go up and do it. Okay? So pretty simple. I mean, through the course of your readings and through the course of the slides, you're going to see slightly more complicated examples, but as far as defining our own functions are concerned, that's how we do it. Anatomy of a function, we have the name right here, multi-cube. We have the arguments A and B, or what we're going to use when we do it. You don't need arguments, but a lot of times they're useful, and you want to pass things into a function. And then you have whatever logic that you need to come to the answer you want, and then you have a return value. And sometimes things don't have return values either. And that's pretty much how functions are defined and used. Now, before we go anywhere, before we go and take a look at something, I want to point out two different things. The first thing I'm going to point out is this. We have to deal, when we deal with functions, we have to deal with a concept called scope. And the concept of scope is something like this. Think of your function as a little mini program that goes off and runs in its own memory space. Okay? So when we first start a program, we're in a big main memory space. Okay? Us programmer geeks call it global space. And when we write a little function and then we run that function, it goes off to another place. It goes off to a memory space on the side that we would call local space, this thing that you're doing at that very moment. And it runs, and then it returns the value. But this is the trick. After it returns the value, it disappears. It's gone. So if I come down here in the main program and I say print Z, what do you think is going to happen? Z was defined up here in my function. So I have a main program. I call multi-cube to get that answer. I get it back. It's 216. And then I come down here and I say print Z. Now, what do you think is going to happen? It blows up. And it says name Z is not defined. And the reason Z is not defined is because Z no longer exists. This function was called with those two parameters. It ran, it returned its value, and then it's out of memory and it's gone. So as far as this program knows right now, there's no such thing as Z. Now, if you're saying to yourself, well, what if I wanted to print out Z? Well, there's a couple different ways to do it. One, we could just print Z here inside the function. Now, if you print Z inside the function, Hold on, I'm just going to comment that out. Well, then you have no trouble at all. It's 6, and it prints right out. Why? Because you're doing it in local space. Z exists when you print it there, and you have absolutely no problem with it. Okay. Now you could also send it back as a return value. Okay. So there's different ways to get Z out. It's not like Z is lost to the world, but you've got to remember with scope, when you go and run a function and that function ends and returns its value, that's it. It's almost like it's scratch work and you're doing a math test. And when you hand in your answers, you don't hand in the scratch work. Well, that's exactly what this is. The scratch work is all being done in here, but you're only getting the answer. The answer is the return value. That's the final answer, and this is all the scratch work. Think about it that way, because this is local space and the whole program is global space. And if you try to print a variable that was in local, but now it's gone because it was a function, you're going to get an error. Okay? Now, there's one more thing I want to do. I am going to comment this out and start running it clean again. Oh, didn't want to do that. There is one more thing I'm going to do, and it's this. I'm not going to print it. I'm just going to run the function multicube 2, 3. What do you think is going to happen? Let's find out. All right, it runs, but nothing prints, and nothing happens. There's not an error, as we can see, nothing blew up. It's just that it ran, and nothing happened. I have my function up here, and then this says call multicube 2, 3. So it ran. It sent back a return value, but we didn't do anything with it. This is where you have to be weary of void functions versus fruitful functions. A void function, kind of like when I printed out the first 4 lines of Detroit Rock City, that just compartmentalizes work. You go off, do this, then come back to me. Fruitful functions return something, a value, something that we want. So when you know you're dealing with a fruitful function, you want to do one of 2 things. You either want to print or display that value, or you want to save it to a variable so that it'll always be there for you to use later. In this case, for something like multicube, I'm going to say C equals multicube, so that I'll have the value saved, and then down here I can say print C, and then all of a sudden you're back in business because you're saving that 216 when it comes back. Multicube comes back with its return value, saves it to the variable C, and then I can print C all day long. Okay, and then this is usually what people do, because then you have it to use. I mean, if you know you're only going to print it out once and that's all you want to do, then that's fine to just use print, but most people will save it to a variable, and then you can use that number for anything you want on down the line. Okay, so those are the 2 things that you want to be concerned with when you're dealing with functions and creating your own functions. One is scope. When you go off to do that function, you're doing it in a little local area, scratch pad area, and after you return that value, all your scratch work goes away. Okay, no more variables, no more junk. That memory is returned to a thing called the heap to be reused by the running program, and you go back to the global space, the main place where you're running your program, which is here. And down here, you can't see what's going on up here, all right, because this all disappears. And I know that's kind of weird because you see it here in your program, but just think about what's happening behind the scenes when your program runs. Behind the scenes when your program runs, this is all in main memory, and then when I call this, I go to another part of memory where I had my function saved, and oh, okay, I can run this, I can run that, and everything works, and then I report my value back, and this all disappears. It all goes away from memory. Okay? Later, I don't know how much later, when we get a little more complicated, we are going to talk about things like this as far as the data structure stacks are concerned, because that's kind of what's going on when the program is run. But I don't want to confuse you, and we don't want to get kooky just quite yet. We will get kooky later, though, okay? So, as I always do, I'm going to put this up in your resources for you to have, for you to play with, for you to do things with, and for you to learn with. But the last thing we are going to do in this particular little function video is go revisit an old friend. By now, you have seen my video, my Unit 2 video, about doing Project Euler, problem number 6. Now, we tackled that problem in Unit 2 when we had arithmetic and sequences and loops under our belt. But now we know about functions. So can you think of a better way to do Euler number 6 using functions to refresh your memory? And I think we can go back and look at it because I have it up on the website. But to refresh your memory, Euler 6 was find the sum of squares from 1 to 100 and find the square of the sum of the numbers from 1 to 100 and find out what their difference is and tell it to me. And what happened is they gave you a worked example and they did it 1 through 10, but they didn't want 1 through 10, they wanted 1 through 100. So what I said at the time and how we coded it with just loops is that it's a good problem when you're learning about computer science and programming because it's not one problem. It's really 3 problems. What are those 3 problems? First, we want to find the sum of the squares. Then we want to find the square of the sum. Then we want to find their difference. So if we take that problem and break it down, it breaks down nicely for something we could implement with functions because it breaks down into 3 different problems. We're not going to do the last one with a function, but I figure the first one, piece of cake, right? Def, square of sums, I'll take a limit n, and I will say, this is where I want to say, s is 0 for I in range 1, comma, n plus 1. Remember n plus 1 because it's the first thing we don't want. For I in range 1 to n plus 1, s equals s plus, and we want to do I, but we want it squared. Then we're going to return s. All right, so let's see if that gives us a good number. Print s, yeah, that'll work. Print square of sum, and let's do 10. What do we get? Source must be saved. Oh, I did save it. Okay, 385. Memory serves for 10. That is correct. So we're in good shape. Now, watch me work. I'm going to take that and highlight it. I'm going to copy it. I'm going to come down here, and I'm going to paste it. And then now what do I want? Now I want the square, the sum of the squares. So what am I going to do? I'm going to do the same thing, except I'm not going to square it. I'm going to add it up. I'm going to square it when I return it. See what I did differently? I'm accumulating all of the numbers. And then when I get one grand total, then I'm going to square it. And that is the sum, is the square of the sums. Is that what I'm doing? Sum of square is here. So actually this should be SQ because this is the sum of the square. And this is your square of the sum. So now at least we have a name properly. And let's go check that and do print. And should I do with a variable? Yeah, you know what? I am going to do that with a variable. I don't think I did this in the past. I'm going to say limit equals 10, print square of the sum, limit, and sum of square limit. Right? Look at that. I think that looks pretty good too. Okay, so now what do I want to do in the end? Oh, the end is pretty easy. I'm going to copy that. I'm going to come down here. I'm going to paste it. What am I going to do? I'm going to take the difference. So let me do that. I can even say the diff is boom. There we go. Why is that so much? I guess I didn't need that. There we go. I'll take it. And 2640, I believe, was correct. So now, well, actually, you know what we're going to do? Make it 100. Run it. I get 251, 64, 150. 251, 64, 150. Now, do we know where that answer is? Of course we do. Project Euler. I logged in as us, PMDS, and I'm going to sum square difference. And, oh, I logged in as the spring because this says it was done in February. No matter. 251, 64, 150. That's correct. That's the answer. So, this is a better way to do Euler 6. I don't know if it's shorter, but to me, to my computer science, computer programming brain, this is a better way to solve the problem. For a couple of different reasons. It's more organized. You have something that does the first part of your logic, something that does the second part of your logic, and then you're just using it. Another thing that is more important after you've read the third part of your unit slides is that from now until the end of time, I never have to code up anything again for the sum of squares. Got that problem licked. Boom. It's right there. I coded it up. And what I would do if this were a piece of logic that I thought I was going to use again in the future is I would put it in a library. I would put it in my own personal tool library, and then I could import from that library, and boom, I'd have it there to use. So when I do things in a modular fashion and I compartmentalize and I write functions to break out and code a certain piece of logic, I don't ever have to do it again. I mean, if it's general purpose enough, and this certainly is, I mean, take a limit and give me the sum of all the numbers from that limit down to 0. I mean, I could see that maybe being useful for something. And now I have that logic all coded up. Okay? So I would never have to do it again. I could take that function and put it in a library and then just have it. And then, frankly, I wouldn't even need the function definitions. It would be a 3-line problem. All right? It would be a 1-line problem if I did it in the print line and I didn't bother with a variable for the limit. I mean, you could, if you had that in a library, it would be one line of code to answer that problem's question, okay? So usually when I do the functions, I do this because I think it shows you a problem that you've solved before and you've seen the solution for, but now it shows you how to do it in a different way, and it shows you how to think about modularity and compartmentalization of your different problems when you have a complex problem. Not complex in that it was hard, but it was complex in that it's 3 different problems. And you need to tackle those 3 different things in order to come to the solution, to the goal state. All right? All right. We are done with functions. So I am just going to throw out a couple of announcements. I'm not going to kill you because videos 2 and 3 are going to be close behind, and I'll hit you with a bunch of stuff. The only thing I'm going to say initially is I will be probably getting you a video soon to talk about your homework assignments for Unit 2. Because your homework assignments for Unit 2 were kind of unique in that they are problems that are familiar to computer scientists. CowPie is really not CowPie at all. It's a famous problem called FizzBuzz. And it's famous because it's often given in computer programming interviews, and a lot of students have trouble doing it. And we'll discuss that. The second problem you got, where you had to use a sentinel loop to jump out of a loop in the middle of a list and count up the negative numbers, is really a famous problem called the Rainfall Problem. And it is very famous in computer science education, and we'll discuss it when we get there. Back in the 80s, in the very early days of computer science education research, there was a gentleman named Elliot Soloway, and he was teaching at Yale. And he gave that problem to students who had finished his beginning intro course. Now, these are Yale students. These aren't people who were attending, Podunk University. And less than 20% could solve the problem. So it was very odd, and it led to a lot of research in computer science education. So we're going to discuss that too. I had you do the negative numbers because I just wanted to reverse it, but I think when Soloway did it, it was just the positive numbers. So we're going to discuss all of that stuff. Be weary, and I know there's still a lot of time, but July 13th is when your midterm is due, your midterm project. So be aware of that. You're going to want to take some time to watch those MIT lectures, to deal with Code Academy, to deal with Learn Python the hard way, and get all that stuff done. Okay? Groups. Very, very shortly, I'm going to be solidifying groups and creating Sakai forums for you all to use. A couple people have emailed me, so that's a good thing. But if you don't email me, I'm just going to assign you a group, and you're going to have to get used to each other, which isn't that bad at the grad school level because everybody's fairly cool and everybody's here to learn. You know, there's not a lot of obstinance or kookiness at this stage, so that's a good thing. So assigned groups usually, will work more often than not. But if you have somebody you want to be in a group with, send me an email and let me know about it. All right? Please, 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 please. And I know I say it, and I know I sound like a broken record, and I know you want me to shut up already. But please engage with all these resources early in the process. That way you will have all, I believe it's usually 3 weeks, but I think you're only going to get something like 17 days. If you read those slides and look at those book chapters in the first couple of days, you will be so far ahead of the game, it will be ridiculous. Because Unit 3 is where the rubber hits the road. And I know, I've been through this process a couple of times already. This is where the students will go, you're crazy, I can't believe this, blah, 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 blah. And it's always the students that wait until 5 days before the quiz to start reading. And then they start reading and they go, oh my God, this is too much. I can't do functions and files and libraries. Oh my. Okay? It's not lions and tigers and bears. Everything is going to be fine. But you've got to give yourself time. And if you give yourself the time to let it soak in, then you'll know by day 2 or 3, you'll be like, oh, I'm going to be okay. And then when you see the homework, you're going to say, oh, the homework is usually we get 2 problems, but this is really 1 problem. Because you're doing the same thing, but you're doing it in a different kind of way. You'll see when you get the homeworks. You're going to get one homework that's going to ask you to create a certain kind of function. And then in the second homework, you're going to use that function. But you're going to have it in a library, and you're going to do some file I/O before you use it. Okay? You'll see what I'm talking about when we get there. Other than that, I hope you're enjoying your summer. It's been a good summer so far. Maybe at some point we'll talk about the criminal behavior that occurred with the referees in the NBA championship, but we'll save that for another time. Actually, in all honesty, truth being told, I am filming this video before Game 7, so I don't even know what's going to happen in Game 7. I'm doing it over the weekend before, so I'm ready, because I want to do all your videos and get them to you while you have enough time to watch them and make them useful. All right? So, everybody's doing good. Watch these videos, read your slides. Everything's going to be okay. All right? Then I'm getting out of here. You be good, and I'll talk to you soon. All right, bye.